Hello, this is Mr. Kenzie's Mixed Up Factoring Review. We're going to start off with number 10. For number 10, the first thing we want to do is you want to look for a GCF. There's no GCF, and there are three terms. This is a trinomial. Also, the A value is 1, the number in front of your squared term. So because of that, we're going to do this by trinomial guess and check. First thing we're going to do is we're going to put two sets of parentheses. We're going to factor our first term. So we have y squared, so it would be y and y. We then take a look at the end. The sign is negative, so the signs are opposite. So 1 plus, 1 minus. Does not matter where they go. Now we want to look at 21, and we need to find factors of 21 that will give us 4. Well, the factors are 1 times 21 and 7 times 3. The only ones when added or subtracted together will be 7 and 3. That can give us a 4. My 7 will be positive, and my 3 will be negative. We then take a look and we check. Our check comes from our OI. The OI are the middle parts of FOIL. Some of you may use the box method. So we're going to take the outers and inners. So we have y times negative 3, which is negative 3y. 7 times y, which is the inside. We then add those to get 4y. This matches up with the original 4y, so that checks out, and therefore this is our answer. The next one we're going to take a look at is number 11. For number 11, we always look for a GCF first when we're asked to factor. There is no GCF, there's two terms. This is going to be difference of perfect squares. So I'm going to break these up into their perfect square. So we have 3x and 3x. 1 and 1. They're separated by a subtraction sign. Difference of perfect squares, difference means to subtract. Now we're going to take two sets of parentheses, and we're going to put 3x here. Now the 3x must come first, and the 1 here. The sides must be opposite. The reason being, when I multiply, I need a negative 1. If it was both negatives, that would be a positive. If it was both positive, then it would also be positive. And therefore, this would be your answer. The next one we're going to take a look at is number 12. For number 12, we have two terms. Always look for a GCF first. And we do have a GCF. We have a common number in 4 and 6. We have a common variable with y. Biggest number that divides into both 4 and 6 would be 2. So we're going to start off, each of these are going to be divided by 2. We are also going to divide by y. Now, not just y. We need to find the smallest exponent that is in common with both of them. So this is a y to the 4th. This is a y squared. Because of that, we're going to have a y squared as our GCF. We can't use the x to the a because they're obviously not the same letter. So when we divide, we have 4 divided by 2 is 2. We have x squared. And we're dividing, so we subtract the exponents. 4 minus 2 would be y squared. For this one, we have negative 6 divided by 2, which is negative 3. Bring the a cubed down. And the y squareds simplify out because 2 minus 2 is 0. Anything to the 0 power is just 1. Notice how inside my parentheses, there is nothing in common. That's how I know I have the greatest common factor. If you had just a common factor, you would have another common number or letter inside your parentheses. Number 13. This is another binomial. We take a look to see if there's anything in common. There is not. So because of that, and there's two terms, this is going to be a difference of perfect squares. So we break this up again. 25 is 5 and 5. Y squared would be y and y. So now we're going to have two sets of parentheses. The 5 is going to go in the beginning, and then we have y. The signs are then going to be opposites. plus and minus. Once again, because we need a negative y squared, the only way you're going to get that is by having opposite signs. You can check this by foiling it or using the box method. That is correct. Number 14, this is another binomial. Looking at it, you might say, well, that's the difference of perfect squares. However, make sure to check for a GCF first. We do have an x in common. So because we have an x in common, x squared divided by x is x. Negative 16x divided by x is just negative 16. Notice how there is nothing in common, and therefore that is my answer. The last one is the most challenging factoring technique just because it has multiple steps. First, we look for a GCF. We do not have one, and it's a trinomial. So this trinomial has an a value, number in front of the squared term, that is something other than 1. And once again, no GCF first. So what we're going to do is we're going to multiply our a term times our c term. So we have 3 times 8. When we do that, you get 24. Now, we need factors of 24 that are going to give us a negative 14. So we have 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Those are the factors. So the only ones that are going to give us a negative 14 would be 2 and 12. So I'm going to rewrite this as 3x squared plus, I'm going to put a blank, plus another blank, and then plus 8. We have 2 and 12. Now, it does not matter where they go. I'm going to put the 12 here. Make sure you attach an x, because it has to be a negative 14x, and a 2x here. The next thing I'm going to do is I'm going to pair them off and find the GCF of the first term. They both have a 3 because 3 and 12 are divisible by 3. And they both have an x. Now remember, it's the smallest exponent, so x to the first. So that goes on the outside, and I divide 3x squared divided by 3x. So 3 divided by 3 is 1. We subtract the exponents. 2 minus 1 would just be an x. 12 divided by 3 is 4. The x's are the same, so they simplify out. Now, if we did this correctly, when I divide these next parts, I should get the same binomial in my parentheses. The GCF here is 2, and only 2 because this 8 does not have a variable. So it's a positive 2, so I'm going to write positive 2 there. I then have 2x divided by 2 is just x. 8 divided by 2 is 4. And as I stated, these should be the same, and they are. So now, I'm going to take this binomial, and now it's in common. I'm going to factor out that binomial. Now, I like to put these in brackets just because it's a little bit different of a factoring technique. And then I'm going to group these two individual terms. So we have 3x plus 2. The last thing that I'm going to do is I'm going to drop the brackets and rewrite this like so. So that was the factoring technique. Review. First one was a trinomial guess and check because there was no GCF, 3 terms. The second one was a difference of perfect squares, no GCF, and 2 perfect squares separated by a subtraction sign. Number 12 was a GCF. Number 13 was a difference of perfect squares because there was no GCF, 2 perfect squares separated by a subtraction sign. Number 14 was a GCF because it had something in common. And number 15 was a trinomial, but it was a grouping because there was no GCF and 3 terms, and the a value was something other than 1. It was 3. Thank you.